Is it working this time? Yes, it's working.
Yes.
Okay.
Less than 0 seconds. More than 0.
Okay, shh. Okay, so finally, this seems to be working here. So, sixth graders, this is 4-7, solving inequalities. It's really more about graphing this time. Although, sometimes when you graph inequalities, that is solving them. So, in this first example here, in example 1, it says the inequality uses greater than, less than, greater than or equal to, less than or equal to, or not equal to compare two expressions. Graph all the solutions of x is greater than 5. Well, if you were to graph x is greater than 5, you might draw yourself a number line and then just put a circle over 5, because that doesn't include 5, but it's really close to 5. And then you would draw a line and an arrow representing greater than 5. Now, it wouldn't be practical, and this is something we touched on the other day, if I said to list all the solutions for something like this. Well, you could put 6, 7, 8, 9, 10, but you have to keep going, and it's just not practical. So you would, to answer this question, you would just graph it. And so that's what they're talking about here. It says the open circle shows that 5 is not a solution, because 5 is not a solution. X is greater than 5. It might be really close to 5, but it's not 5. And then step 2, it says find some solutions and plot them on a number line. So they just happen to pick 7 here and 9 here. Those are all solutions because they're greater than 5. And then it says, put your open circle over 5 and then draw an arrow to the right showing the solutions that would be greater than 5. You wouldn't list them all. There'd just be too many. And then it says, be precise, inequalities have infinite many solutions. And this means that there is an unlimited number of solutions. Infinite many means it doesn't end. And so look at this for a moment here. You guys pay attention. I wrote down x is greater than or equal to -2. So here I drew a little graph of -2. And x is less than or equal to 2. And so then I had 0, 1, and 2. And since they include -2 and 2, I put a solid dot over each one of those and then just a line between them. Now, you might say to yourself, well, there isn't going to be an infinite number of solutions. There's just -2, -1, 0, 1, and 2. That means there's only 1, 2, 3, 4, 5 solutions. How do you get infinite number of solutions between two numbers? Well, is 1/2 a solution? Yeah. How about, is 1/4 a solution? Yeah. How about 1/8? How about 1/16? 1/32? 1/64? I can keep going, Mr. Quaylar, and making the numbers smaller and smaller and smaller. You might want to turn around and kind of watch what I'm doing up here. Okay? And so that's why there's an infinite number of solutions, even just between 2 points. The numbers can keep getting smaller and smaller and smaller. All right, down below in the try it, we already talked about this here. It says graph all of the solutions of x is less than 8. Well, it's going to be an open circle above 8 because it doesn't include 8. And you'd shade the solutions to the left of the open circle you drew at 8. And that's what I did here. And that convinced me, it says, how does the graph of an inequality change when the less than sign is changed to a greater than sign? So how would that change? Well, the circle stays at the same place, but what you would shade and the direction of the arrow would be opposite. So right now it's pointing to the left, representing less than, but if I was to change it to greater than, the circle stays the same over 8, but then we would just shade it to the right and point to the right. All right, example 2 and 2, I'll let you look at those. Let's look at example, the triad actually. It says there are no menu items on the children's menu at the Flamingo restaurant. that cost more than $8.50. So there's nothing more expensive than $8.50. What are all the possible costs of the items on the children's menu? How would we represent that? Well, here's 7, here's 8, here's 9. So $8.50 would be right there in the center. Does this statement include $8.50? It does. So I would put a circle over $8.50, and I could put 8.5 right here. Okay. And it says there are no menu items on the children's menu at the restaurant that cost more than $8.50. So $8.50 is the max. So would this be a filled in circle or an open circle? What do you think? It would be filled in because it includes $8.50. And it would point to the left because that's the maximum amount, $8.50. All right, you can look at example 3 on your own, and I'm not worried about the try it at the bottom of the page. We went over these already, but for those that are absent, number 1, it says, how can you represent the solutions of an inequality? You graph them on a number line. That's one way to do it. Or you can substitute the values into the inequality to see if they are solutions. Number 2, in example 1, why is 9 a solution of x is greater than 5? It's a solution because 9 is greater than 5, so that's a solution. Number 3, explain why 2 is not a solution of x is greater than 5. Well, because 2 is not greater than 5. Number 4, how many solutions does the inequality x is greater than 12 have? And it says to explain. Well, there's an infinite number of solutions, or infinite many, because there's a whole lot of numbers greater than 12. And then number 5, it says, how do the graphs of the solutions of inequalities involving greater than and greater than or equal to compare? Well, the greater than has an open circle, and greater than or equal to has a closed or filled in circle. And I would add also, and I didn't put this down, they're both going to have a shaded area or an arrow pointing to the right because we're talking about greater than. 8, 9, 10, and 11. I want you guys to do those. Let's see number 6 here. It says, write an inequality that each graph represents. So here's the graph I'm looking at. There's a circle over 14. Does that include 14? It does not. So it says z is something in relation to 14. Z, and the arrow is pointing to the left. Z is less than 14. And then let's look at number 9 here. It says for these here, it says substitute each given value of the variable to find which, if any, is a solution to the inequality. So I'm looking at t is greater than 25. So if t is 24, would that be a solution? Is 24 greater than 25? No. So that's not going to work. How about 25? It says, is 25 greater than 25? So no, that's not going to work. How about 25.1? Yes. Yeah, that works. How about 27? Yeah, so 25.1 and 27. Those are the two solutions out of the ones they gave us for number 9. Next page. I think I circled them all. Yeah, so 12 through all the way down to 28. I want you to do all those. Let's look at number 20 here. it says name three solutions of each inequality. So x is greater than 10.5. So this is totally subjective as to what you put down. So a solution for this one would be 10.6 because that's greater than 10.5. A solution would be 10.7 and 10.8. So they said to list 3, so I just put down 3. I could have put down 11, 12, and 13. I could have put down 100, 101, 102, 100, 200, 300. I mean, there's all kinds of things you could put down. I just put down 10.6, 10.7, 10.8. What's that?
You put down 4,492.
I could put down 4,492. That would be a solution. Okay. I think I'd just run out of room if I kept having large numbers like that. Okay, next page. Yeah, I circled all of those. Also, number 29, it says graph the inequalities. X is less than 2. I'm sorry, x is greater than 2 and x is less than 2 on the same number line. And it says what value, if any, is not a solution of either inequality. So first thing I'm going to do is graph x is greater than 2. So what do I put above the 2? Let me pull a stick here. Miss Daly's not here. Mr. Moore, what do I put above? So again, I would just circle over 2. So put up 50 points. Now, graph the inequalities. X is greater than 2 and x is less than 2. So I could just draw an arrow like that and an arrow like that. And then it says what value, if any, is not a solution of either inequality. What is it?
2.
It's 2. Everything else is a solution. So only 2. All right. Number 30. And we only got a couple minutes left here. Death Valley is the hottest place in the United States. The highest temperature ever recorded there was 134 degrees Fahrenheit. The lowest temperature recorded there was 15 degrees Fahrenheit. And then write 2 inequalities that would describe the temperature in degrees Fahrenheit in Death Valley at any time since the temperatures have been recorded. So I did the first part for you. T is less than or equal to 134 degrees. And you fill out the rest. T is, and it's going to be concerning the 15 degrees, but you figure that part out. Circle 31, 32, 33, 34, 35, 36, and 37. Questions, anybody? All right, good. Gosh, with a minute to spare, we were able to